नमस्कारम स्टूडेंट्स, आज हम यूनिट 7th थर्ड सेमेस्टर केमिस्ट्री बी.sc के मल्टीपल चॉइस क्वेश्चंस करने जा रहे हैं। आज का हमारा चैप्टर का नाम है थ्योरीज ऑफ कोऑर्डिनेशन कंपाउंड्स। टॉपिक फर्स्ट, मेटल लिगेंड बॉन्डिंग इन ट्रांजिशन मेटल कॉम्प्लेक्सेस। फर्स्ट क्वेश्चन, व्हाट इज द प्राइमरी लिमिटेशन ऑफ valence bond theory (VBT) in explaining metal ligand bonding in transition metal complexes? Option A, it cannot explain the magnetic properties of complexes. Option B, it fails to account for the color of complexes. Option C, it does not consider the hybridization of orbitals. Option D, it ignores the shape of the complexes. And the answer is option number B, it fails to account for the color of the complexes. So VBT does not adequately explain the electronic transition responsible for the color of transition metal complexes, whereas crystal field theory CFT provides a better explanation for these properties. Next question. In crystal field theory, the splitting of d orbitals in an octahedral field results in option A, two sets of d orbital with equal energy. Option B, three orbitals T2g at lower energy and or two orbitals Eg at higher energy. Option C, two orbitals Eg at lower energy and three orbitals T2g at higher energy. Option D, a higher or a single set of d orbitals with 5 different energy levels. And the correct answer is option number B, 3 orbitals T2g at lower energy and 2 orbitals Eg at higher energy. Explanation. In octahedral field, the d orbitals is split into two sets, 3 lower energy T2g orbitals and 2 higher energy Eg orbitals. Next question. Which factor does not significantly affect the crystal field splitting parameter? The nature of the metal ion, the oxidation state of the metal ion, the nature of the ligand, the size of central atom. And the answer is option number D, the size of the central atom. The crystal field splitting parameter is primarily influenced by the nature of the metal ion, its oxidation state and the nature of the ligands, but do not significantly by the size of the central atom. Next question. Now topic second, crystal field splitting in different geometries. In a tetrahedral complex, the crystal field splitting parameter del T is approximately equal to del O octahedral, twice del O, half of del O, 1/3 of del O. And the answer is half of del O. Now the crystal field splitting parameter for a tetrahedral complex del T is approximately half of the splitting parameter of an octahedral complex del O. Question number second. The Jahn-Taylor effect or the John-Taylor effect is most commonly observed in which type of complexes? First, tetrahedral complexes with D1 configuration. Second, octahedral complexes with D9 configuration. Third, square planar complexes with D6 configuration. Fourth, tetrahedral complexes with D5 configuration. And the correct answer is option number B, octahedral complexes with D9 configuration. Explanation. The John-Taylor effect is often observed in octahedral complexes with configurations like D9, where unequal occupation of degenerate orbitals leads to a distortion of the geometry to lower the overall energy. Question number third. In a square planar complex, the crystal field splitting pattern for the d orbital is A, similar to that in tetrahedral complexes, B, similar to that in octahedral complexes, C, different with dx2 y2 at the highest energy, D, different with dxy at the highest energy. Now the answer is different with dx2 y2 at the highest energy. Explanation. In square planar complexes, the dx2 y2 orbital is at highest energy due to the direct interaction with the ligands in the plane, resulting in a unique splitting pattern compared to tetrahedral or octahedral complexes. Topic 3rd. Thermodynamic and kinetic aspects of metal complexes. First question. Which concept differentiates between hard and soft acids and bases? The pH of the solution, the size and charge density of ions, the color of the complexes formed, the magnetic properties of the ion. And the answer is option number B, the size and charge density of ions. Explanation. The HSAB concept is based on the size and charge density of ions. Hard acids and bases are small with high charge density, while soft acids and bases are larger with lower charge density. Next question. Stability constants of a metal complexes can be determined using A. Conductivity measurements, B. colorimetric methods, C. magnetic susceptibility, D. solubility test. And the answer is colorimetric methods. Explanation. Stability constants of metal complexes can often be determined using colorimetric methods by analyzing the absorbance of solutions at specific wavelengths corresponding to the metal ligand complexes. Next question. Which factor does not significantly affect the thermodynamic stability of a metal complex? A. The nature of the metal ion, B. the significant field stabilization energy, C. the enthalpy change during complex formation, D. the shape of the ligand. And the answer is the shape of the ligand. The thermodynamic stability of a metal complex is influenced by the nature of the metal ion, ligand field stabilization energy and enthalpy change, but the shape of the ligand is less significant in determining stability. Topic 4. Substitution reactions of square planar complexes. First question. Which type of mechanism is most commonly associated with the substitution reactions of square planar complexes? A. SN1 mechanism, B. SN2 mechanism, C. associative mechanism, D. dissociative mechanism. And the answer is option number C, associative mechanism. Explanation. Substitution reactions in square planar complexes often follow an associative mechanism where the incoming ligand coordinates to the metal before the leaving ligand departs. Next question. In a substitution reaction of a square planar complex, the rate determining step typically involves A. breaking of the metal ligand bond, B. formation of an intermediate with higher coordination number, C. loss of a ligand from the coordination sphere, D. reorganization of the ligand field. And the answer is option number B, formation of an intermediate with higher coordination number. And what is the explanation? The rate determining step in the associative mechanism involves the formation of a 5-coordinate intermediate before the substitution is completed. Third question. The stability of square planar complexes is often enhanced by A. the presence of weak field ligands, B. the presence of strong field ligands, C. low oxidation states of the metal, D. high temperatures. And the answer is option number B, the presence of strong field ligands. Explanation. Strong field ligands increase the ligand field stabilization energy, enhancing the stability of square planar complexes. That's it for today's video. Please subscribe to my channel, like, share and comment. Thank you.